Welcome everybody to Enterprise Scale AngularJS. It's quite a thrill that it's so completely packed, and it's still, I think, a sign that Angular is very much alive. We saw some discussions on the Twitter feed and asking, is Angular still cool? Has Google abandoned it? Well, we don't think so, and hope we'll prove it to you as well. Who of you has worked with Angular before? Great, that's a lot. And how many of you have worked with Angular on a big enterprise scale? Well, aside a lot of colleagues, that's quite a few. And when we started out with Angular in the early phase at ING, we're working, there was quite a few people on the internet warning us, Angular is not ready for the enterprise scale. You run into problems. We didn't believe that and started out and want to share our experiences with you today. Well, I'm Remco Vlierman, developer, software architect. I work for myself, but the last 2 years I've been busy at ING. And I'm here with
Mischa Dasberg. I'm a software architect at JPoint, and I've been working in the enterprise Java environment for more than 10 years. I'm also an Angular enthusiast. I've been working with it from the early stages.
So what will we be talking about? Straight from our abstract, this very long and boring sentence, about how we moved the ING away from a server-side rendered HTML site towards a single-page app using Angular. But we also wanted to tell you about a lot of fun we had, because it's coding with Angular is really a new standard, I think, and it's one of the most exciting things to happen to front-end web development in the recent years.
Yeah, so what do we perceive as enterprise scale at ING? At ING there are more than 300 dev engineers working on the same code base. They are divided across more than 40 teams and working for multiple channels. And with the channel we mean at ING you have the open environment, which is the part where you log in or where you don't log in, but you go to find information. Then you have the restricted part, which is the part where you need to log in and see all your accounts and transactions and stuff like that. And then of course you have the semi-open offices and call centers. And for a customer they perceive it as one. So there's only one application, and they actually want it to work in one particular way. They don't
Customers don't really care about whether they're on a website or an application. It's one company. Stuff should work, feel and look the same way across all the user domains.
Yeah.
So what were we addressing? The past at ING, where did we come from? And why wasn't this sufficient anymore? Because obviously it has worked before. So what problems did we run into? Early in the migration process we started setting some goals. So what do we want to achieve? And after that we want to share a solution or answers to these goals that we formulated.
Yeah, so where did we come from? Well, as most banks, we came from a traditional stack using Spring Web MVC, a lot of JSPs, custom tag clips which interacted with our jQuery building blocks, which started out as generic components, but in the end they were massive and tested. Well, there was actually one test, I think.
Somewhere deep down in ING there was one front-end code test which amounted to 0.001% coverage, I think.
But nobody dared to touch it, and that wasn't acceptable anymore. To give a little bit of an insight, the backend and the front-end were deployed as one, of course. The backend was fully tested, front-end wasn't. So what we did was, when we sat down with a couple of people to figure out where do we want to go to, is we needed to split up the front end from the back end. So for the new setup, keep in mind that the back end is fully RESTful. Front end, we'll get to that later.
So what do we need then, coming from this background? Well, I started creating a shopping list, and we needed, first of all, testable code. Structured, maintainable, flexible. This kind of open doors to kick in, but it's important to realize that we were far from this. So we go on, we started shopping, and then we thought, what does Angular provide us with? A small sidestep, most of you have seen this probably. It provides a MVC pattern on the client side in your browser. And there's quite a few libraries doing that these days, and Angular is one of them. It provides dependency injection. It was a concept not known to JavaScript before Angular, I think. Two-way databating, templating, and all this helps us in structuring our code, making it extendable, making it testable. And on top of that, Angular has built-in testing support, Karma for unit testing, and Protector for UI testing. And we use this to put up multiple browsers across multiple platforms and test our applications, among all this stuff. And on top of that, we have even mock support, so we can completely test our backend, fully separate from our backend.
Yeah, so it was a good candidate for what we were actually looking for.
And the one we chose. So we set some goals. So what do we want to achieve with this whole migration? What do we want to do with Angular?
Yeah, so the first goal we set was increase output. We sat down with the business and almost the only thing that they wanted is create new features and change them more rapidly. It used to take about 4 months.
Not a big surprise, by the way.
It used to take 4 months for a new feature to go into production, which wasn't acceptable anymore. So our second goal was create a continuous delivery street. We wanted to go to production every 15 minutes automatically with the complete front-end code base. And to do that, we needed to change the way of working. So we needed to actually create smaller increments and go with them to production more rapidly.
Yeah, and it's not really about making this goal. For us, it was more about setting this goal and setting the target very high, more maybe like a dot on the horizon, something to strive towards. And if you strive towards this goal, you will learn how to make these small increments. You will learn that you need tested and well-tested code. So everybody can write a few tests and get decent coverage. But if you go automatic to your production environment, you really want to make sure that your code is tested well. So we try to enforce a way of working, actually.
Yeah, so the third goal that we set was uniformity. As we already said, a customer wants to perceive one way of working. They have one look and feel. Every form works the same way. It's a little bit confusing to have, if you are on the open environment and on the restricted part, that you have two different ways of working. So therefore we needed uniformity, and from the past solution that we had, we couldn't actually do that because there were at any given time, for instance, 14 different versions of an account selector in production. So if we would like to change an account selector, that would mean deploying 14 different applications at the same time to actually achieve the same goal. So when we started looking at the solution, looking for a solution actually, we thought, what did we actually learn from what we used to do? So one very important thing was focus on quality and not on speed. We used to focus on speed. And you can see that because there were actually no tests and all the components were not generic anymore. So
well, we started out pretty quick actually when we focused on speed in the beginning, because you will be able to deliver very fast. But because you don't work in a generic way, it really was a grinding to a halt. So that's why we said when we start out we focus on quality. It will take us longer to develop some stuff and new components, but in the end it will pay off, and it did actually. So what did we wind up with? We created something that we call the guide, and basically we created a website. It's an intranet website that lives on the ING domain, and the subtitle says it's a platform for fast and easy front-end development. And what we try to do is create a platform where UX designers and developers kind of meet. It should allow the UX designer to rapidly make prototypes of all the components that are already there. So we have a lot of generic components that you should be able to just piece them together like little Lego blocks and build something. In this way, we try to enforce them to think of a bigger picture. So if we have a generic component and that's already been found on 30 or 40 pages, and one UX designer decides, I want a tiny change to that, why do you need that? Because those 40 or, at ING case, sometimes 100 pages can live without it. So what makes your single page so special? And what we ask of them, just go back to your UX friends and talk to them. And if it's going to be a new generic pattern, of course we're happy to build it. We are not going to build it into the library straight away. So this helps in ensuring a bigger mindset on uniformity.
Yeah, so it bridges the gap between the UXers and the developers, and that's
what we
actually
try to do. And of course the developers can use these components that are made if UX comes up with a new component, and we can use it straight away in our applications. So let's look what's beneath the guide. We have 3 pillars. I'm going to introduce to you them, and then we're going to dive into them a little deeper, and after that I of course show you what we came up with. First pillar is of course a style library. It's CSS based, and it brings us to the goal of uniformity and styling. The second is a component library. We call this Spectangular, and you can see we build it on top of Angular, and it creates a uniformity in behavior. It will create an increase in output because you can use all these components as is. You don't have to tweak them or invent them anymore. And it makes it very flexible because we have very strict rules in one component does one thing. So we can easily add small components to change or augment behavior. And the third pillar are automated builds. We need quality assurance. We need continuous delivery. Automated builds can do this for us. So style library, let's not this code convention, so let's not go very deep in the whole stuff, but it's Bootstrap 3 based. It's extendable. We try to keep it as lightweight as possible by using techniques as dry CSS. I heard very good things this week about material design, and we will look into that as well, I think, in the future. But for now, this is what we have.
Yeah, so the second pillar that we created was the component library, and it actually adds behavior to the components that were already defined and specified by UX in the style library. Very important is that there's only every component has only one function, so it's easier to unit test. We can create page objects to make UI testing more easy and flexible. And of course, everything is documented. So as you saw on the previous page, you see there's a class navigator, which actually results in a ING navigator in this instance. And you can see that we actually split up the components. So we have an ING navigator and we have a navigation header, which actually is the part where the breadcrumb, for instance, is. We'll show you that later on. So and the third pillar that we created was the build. And the build actually lets us achieve the goal of continuous delivery. It is an automated system which gathers all the information and all the dependencies that we need in production. And the next phase will be, of course, the testing. So every project that we build is tested against the code base. It's minimized. It will, of course, package the stuff and make it available for continuous delivery. So what do we actually build? Well, our component library we actually call Spectangular. And the Spectangular library contains all the components and filters and stuff that we need to make a uniformity and a standardized way of working. And every module that is using Angular and Spectangular is built in the same build system. So if we change a core component, every project that is using the component library is automatically tested against the latest version of the code base.
So this is like an automatic regression testing, if you will. If we change a generic component, the whole of the front end needs to be retested, and we'll do this continuously. So we have a continuous integration cycle this way.
Yeah, so what we are actually doing now is we are a little bit refactoring our current build system to implement life cycles. And for those who already know Maven and Gradle, they're used to the life cycle phases like test, verify, integration test and stuff like that. We use Grunt as a task runner. for our build system, and out of the box it's just a basic task runner, so you don't have any life cycles. So what we're now doing is changing and creating all those life cycles that we're used to use when building a Java application using Maven, for instance, and actually assigning specific tasks to specific life cycles. So in the prepare phase, we have we fetch all the dependencies that we need in production using Bower, and then in the next phase, the test phase, we will actually run all the verification tests like JS Hint, Karma for unit testing, Protractor for UI testing actually. And we do a couple of other tests like check if there is specific CSS, or teams define their own CSS, which they shouldn't use because we have the style library. But in the end, everything is packaged and made available for continuous delivery. So the packaged distribution is put in the Nexus repository, and then our deploy tool, Nolio, will pick it up and actually deploy it on the delivery environments.
So with all these, if I can intersect for a moment, we have all these cool tools built on Node.js, like Grunt, Bower, Instabool, Protector. And together we created something that's very much like the Maven tools you know, but completely focused on JavaScript. So I think this is really, if you don't know these tools, look into them, because they are really valuable and they integrate really well with your JavaScript environment. So do look into that.
Yeah, so what is the result of the build? Well, it's actually a fully tested code base against the latest the latest core library and style guide that we put in production. So if your test doesn't meet the thresholds that we set for your for the delivery environment, so for instance for the development environment, you need to have a test coverage of at least 85%, which is actually a goal to get developers to write tests. But if you don't meet the threshold, or you have a failing test, or something goes wrong, you will not get deployed on the environment. You will actually be removed. So that's a way to actually give the team the pain of actually do it right, instead of make a quick fix, see if it works. That's not possible anymore. They actually need to write tests and make them pass. And after that, everything is of course deployed, as we already said, and the continuous delivery cycle is going to start.
So when we're ready to deploy, we do this a lot. We do this constantly, like we said. And deploying of your static resources should never be more than copying some files to a file system somewhere. So a lot of times in the old way, and we did it this way too, statics were packaged within an ER or within another kind of application and put in there. This makes it very interchangeable, and we tried very hard to separate this front end from our back end. So don't do that anymore. It's a matter of copying files. What we do, the build creates a zip file, we put it in Nexus, and Nolio, this is our tooling, but a lot of tooling could do this, of course. Just takes the zip out, unzips it, and puts it where we want it. And we have multiple environments to put it to, so that's well, fairly easy. We do this every 10 minutes to the dev environment. Every 20 minutes to test, and every 2 hours to acceptance, and at the moment manual to production. But we're in the process of actually doing automatic production deployments. So we really came a long way across our goal. And we do this, I think, to production now more than 800 times. That was the last time I checked. And we have had one time we stopped it because we found an error, and one time we stopped after the first cell because we found an error. And I think that's an amazing track record. There were no mistakes in production so far, and we're almost doing it automatically now. Yeah,
and on an average day, we probably deploy 2 or 3 times. We actually did it
8 times was the top to production in a day. So we really learned to make real small increments and do them in a row. And we don't roll back anymore, we roll forward. Because we can do it, deployment takes us about 5 minutes. It's unzipping a zip. So we can do it a lot, and if you find a mistake, leave it there, pull the fix through the OTAP street and deploy it again. It's really fast. Of course, like Mischa said, if you do not meet your thresholds or you have failing tests or anything like that, you're going to be removed from the environment. So we needed to create a way of giving feedback about the health of your app. So we have 4 of these dashboards that are in for each environment one. And you can see, for instance, the code coverage you have. If you see the first meter, it's red, and red is bad. So they're not on the environment. And next to that, it's a bit small, but you have a list with all the field modules. You can click on them, and you can see which tests are failing. So you get instant feedback across all test suite or what you do. Because we have these demands already on dev, we do not get any mistakes in production anymore. There is no untested code on our environments anymore. That's what we said when we started out. And it really pays off in the long run.
Yeah, so there's a little bit of a difference between dev test and A and P. On P, no project can fail because we cannot remove a project from production. But on dev test and acceptance, we just remove the application.
So before we show you what the guide looks like and start building something with it, this is what we have. We have a style library that contains the look and feel, a component library that adds behavior with a very strict separation of concerns in terms of implementation, one function for a component, all this stuff. We're very rigid in this, and a build suite that assures the quality. And in the long run, it means developers should implement and not invent the components. Components are invented by UX. We create them in the component library, and the developers who create an app implement this stuff.
Yeah, so if a team will actually start, they can do it much faster and more reliable because everything is already thought up.
It's there, it's tested.
Yep.
So let's take a detour to the guide, I think. So, like I said, it's not, it doesn't look impressive because it's a website. But if you go to the homepage, this is where most developers would start, or where UX would start. And this is still very much work in progress. We have plans to add a lot of UX rationales into it. But this is what we have. It's a homepage. You can find the Git repositories at the bottom. So you can actually check the Spectacular core out for yourself. You can make changes. So if UX said, well, we want new behavior, and you're the volunteer to implement it, you create a pull request, and we have a group of committers that will review all the code changes, and everybody's happy. We merge it, and we have a new feature for everybody to use. Well, if we look into the first tabs, these are for the styling, and it's quite similar to the way Bootstrap does its documentation. If you look at the animation, we have a working example, and below there's some markup which you can basically copy-paste into your application, and you will have it working. And if we dive deeper, you have alerts, very much the same way as Bootstrap does it, and our users make a lot of mistakes, so we need a lot of alerts, of course, or info boxes. Again, the same thing, a developer would try to copy-paste it.
Yeah, but it would be a shame if developers would actually write these lines of codes, because if they do this, we do not have any control to make it changeable. So if, for instance, we change the style class to alert 2, which would be pretty stupid, but give it another name, every project that is using these markup would need to change their code. So we created Angular components, as we already said. And for each component that has an Angular representation, we put a link on the top of the page. And it will automatically go to the component that we created, which is the representation in Angular. So the alert, we call it, our Angular component, we call it ing notification. And what it actually does is it's just an element or attribute directive that you can use. And you can specify what type of notification you actually want to represent. So you can show an error or warning or an info or success message. And of course you can make it closable and a couple of other parameters you can provide it with. So looking at the code over here, it's actually a lot clearer. You want to represent a notification of type info, and it doesn't. You're not interested in it as a developer which style class you should use. So this will actually represent. This is actually the working version of your notification directive, and teams actually use this, so they can quite easily use the already built components. And to give an indication how it works, every team can create a sandbox, and in that sandbox,
this is kind of where we said we also needed a place where you can make prototypes. So we created for each prototype that a team wants, we create a separate repository, which we call a sandbox.
And over here you will see a complete working application, just plain HTML.
And of course they made a mistake by putting 2 buttons. But,
but as you can see, this is all made using the style library.
And this is actually quite interesting, because if everybody follows this, and we said it's not just a playground, but you should have an actual representation of your app's HTML in here. So we have a fully built HTML source of our whole website, of the whole. This is more this the closed environment actually. Yeah. So we can do testing on this. We can do CSS testing. We can do responsiveness testing. We're in the process of creating this, but we have it separate, so we can use this.
Yeah. So if, for instance, the UX design specifies that every orange color should be purple, we can now actually change it. So I just checked out the style library, and if I go to presentation mode,
there's always a chance that UX is getting tired of our plain old orange, so let's see if we can make it a different color maybe.
Yeah, so it's split up in foundation, typography, colors, and then if I go to the variables, I can actually change the color orange, which is now orange, and if I make it purple, we have a watcher, grunt task watching our changes.
This is where grunt comes in. It has some cool built-in features, and it can watch your entire code base.
Don't mind the errors.
And it can watch the complete code base. If you change one file, it will rebuild everything. We do this with less, and it will result in a new CSS. And our nice little guide viewer will watch changes in the CSS. So if we reload it, everything with the color orange is now purple. And because we set it up real in a modular way, you can see that it's inherited everywhere. So this is, and this is not just if we reload the viewer is purple, all the modules are purple, and even if you start developing a module, you will immediately get the latest version of CSS.
Yep.
And this is where, again, Bower comes into play. It does the dependency management. So if you're developing an app, and somewhere on the other world of the ING, somebody changed the color to purple, you just type Bower update, and you will have the new CSS there for you. And having all this HTML in the sandboxes also allows the UXers to see, well, they experiment a little bit locally, you change it to purple. How does that work for me? Does it work for the whole application and not just my pages? So this is again helping with a bigger picture we talked about.
Yeah, so I changed it back to orange again, and now we're going to do some live coding. So if a team, no, first let's talk what we are going to present. We are going to create a wizard, a navigator, in which you can change your personal information. We are going to start by going to the documentation page. So if a team wants to create a navigator, they probably go to the documentation page and type in and there it is.
So navigator is something that Angular doesn't provide you with by default. So there probably is a component for that, because the bank has a lot of user flows, which the wizard or navigators, whatever you want to call it.
Yeah, so if a team starts, we actually generate an application using a JPoint generator that we altered to meet our standards. And it will automatically give you a working application. So everything is set up. You get the configuration files for Karma, for unit testing and end-to-end testing. And over here you see the working example. So it's basically a simple HTML page. And If I now would go to the documentation application, go to the navigator, I should actually be able to copy-paste the example code that is over here. So if I would copy this, put it in here, and go to the demo, it would actually give us a working navigator without even having to write any JavaScript at all.
This is almost like the Angular take on what web components are. These are fully functional components that work without scripting, doing any scripting yourself. So that's what we try to give you to. And you see they're very much separated to a navigator tag, a navigator step tag, a navigator header tag. They're all separately tested and you can use them separately.
As you can see, this is in Dutch, for those who are Dutch. If I would like to change the label on a specific step, I can easily do it. I go to the documentation page, look at which parameters I have available, and over here you see there's a label for the next button, which is called next label. So if I go to the HTML, which I just copied from the page, and say next label, next, and go back to the example, it will be next. So still there's no JavaScript at all.
So we have a web component-like thing in Angular with an interface we defined. And you can see that also there's a template interface on it. So you don't have to type your HTML within here. You can also split it up in separate templates, which makes your app much more readable for your colleague developers.
So I already created some steps.
While Mischa's typing, it might be interesting. We render all the documentation with ngdoc. It's the same stuff Angular themselves use, so we thought it would be good enough for us. And you define in comments, you define your documentation. So when a component changes, you immediately change your documentation, of course, in the comments. And it will be rendered automatically on the guide.
So let's call our navigator devox. And now I just already, I changed the templates to actually point to the template I already created. I will show that in a minute. But it will actually fetch the template from that path. So now I still have a working example.
Okay, but let's talk about validation a little bit, I think. Yep. If you could pull up the first form. Because there's some, of course, we need validation in our forms. And we have this phone field. I think it's actually a mobile phone field. And UX has some special requirements regarding the validation. Angular validation goes on change. And that's the good model. Because if a field is empty and it's required, it is invalid. But we don't want to bore our users straight away with all these red crosses when they enter a form. Or when they haven't even entered something in the field. They did not do anything wrong yet. So our UX said, we want to have the validation on change. Well, we said, well, the field is invalid. We're going to control the way when the errors are shown. So they are shown on blur, and they are invalid, actually, in the beginning. So we created something that the validation group, and that kind of listens to its child input elements, and whenever it triggers a blur, it will display the errors. So we have a very small piece of code that does just one thing. It handles the showing of errors, of validation errors to the client. And also we needed to be able to combine some messages. In the Angular 1.2, and they fixed it in 1.3 actually, you can have one error at a time in 1.2. Because you have to return an undefined in your validators. That didn't quite work for us, because we wanted to combine our error messages. So we don't want to have the users think, oh, I did 4 things wrong, because there are 4 big crosses. But we say, no, you did this wrong, and this. And we want to combine the sentences, so we have a much user-friendly approach. We have an ing notify for that. And that's able to take an expression, and you can, as you can see, if you can highlight the... so for instance, we have a Dutch phone number validator. That checks where it's a valid Dutch phone number, basically, and where it's a mobile phone number in Dutch. So you can combine messages by just saying, well, I want to show this error if both are wrong. or I want to show this error in the sentence in the notify below. When it's a
But it's actually not a mobile phone. Yeah, so
it's very hard
it
with
can be
validations and the negations, but we'll get there.
So if I just refresh, this is a valid phone. So I step in, step out. If there would be an error, it would show it. So if I remove one digit, it's not a valid phone number. It actually says it's not a valid Dutch phone number, but it's a Dutch mobile phone number has this syntax. So if I would now fix it again, it would be correct. But if I would create a Dutch home phone number, now it gives another message, because it is actually a valid phone number, a Dutch phone number, but it's not a valid mobile phone number. And that's this expression.
So we had some UX requirements that we couldn't do out of the box with Angular regarding validations. But we never tweak the way Angular does things. We just augment it. So we have this notifier, we have custom validators that do their own thing. And again, to create this, you do not need to program a single line of JavaScript.
Yeah, so
as the implementer, that is, of course.
Yeah, so if we now have actually a invalid form, and if I would press next, it goes to the next step, but it's invalid.
We should have something for that.
So, as a developer, you would probably go to the navigation service, which the controller, and see what we can do to actually intercept the next button, so we can validate our form. So what you see over here is there's a method called addCallback, which allows us to actually return true or false, so we can actually know and intercept the next button from going to the next page.
This is a small API to the navigator. Whenever it wants to navigate to a next page, you can add a callback to that. And if it doesn't return true, it will stop doing what it's doing.
Yeah. So this is actually the complete code base of the code that we wrote for this demo. As you can see, we have an Angular module called DevOps. We created a controller called Step1 controller, and we injected some services. And over here you see the navigator service. So if I would now like to add the callback, I would just write service .add callback, specify the step, which was the first parameter, I think, yeah, the ID of the step. So that's step 1, and give it a function. And now I can say return false. So if I now go to the demo, doesn't matter if I have an invalid form or a valid form, it just doesn't navigate. So to be able to actually see if the form is valid, we just say scope dot. Let's go to the HTML page, see how the form is called. The form is called change personal data.
So this is all basic Angular, as you, the ones who who write Angular know this. And we always try to stay as close as possible to the Angular way of working. So we just hook into the form.valid methods and the objects it provides.
So it now navigates only when it's valid, and if it's invalid, it doesn't. So what we actually want to do is, if we go to the next step, we want to make the data that we changed, or actually the entire model that we put on the first step, make it available on the second step. So what I can do now is just say if valid service, which is the actual instance that we got from the service. So it actually gets the instance object for this navigator, and I can just call the object state and say $scope.model, which is actually the model which contains all the data. So if I now go to the next step, you can see I just printed out the information from the model in the next step. It's just basic two-way model binding. Oh, presentation note. And it will represent the data on the second step.
So now for the interesting part, testing.
Yeah.
Of course, this application is very well tested by unit test and protector. We provide them with grunt configurations to run tests. So if you just type grunt, it will start running all the tests. And we'll do that now and see what happens. We've written some tests before.
It's now running that were already the unit tests, and now it's going to start up two browsers containing.
So you see it started Firefox and Chrome, so actually it's testing against two browsers at the moment. And I can never get enough of seeing all this happening every day. That's pretty cool.
So now you can actually see all the tests are correct. So we created some tests. It's a little bit hard to read, I think, but all the green tests, the first one said it should have 2 steps. And over here it should navigate to the final step when pressing next. And if you go actually to the code base, to the test, if a developer would write a test using plain protractor syntax, it would probably do something like this: element.byid, get the navigator, and then find the footer and find all the buttons, and I would probably click on the second button.
So Protractor gives you all these methods to interact with the DOM, get elements from it.
Yep.
And we click on that actually.
So this actually works, but what would happen if we change the code?
But this is an actual use case that we had. We had this wizard complete, and then UX said to us, well, we need to reverse the order of the buttons, because we did some research and people like the next button on the other side better. It wasn't true, so we changed it back. But we're going to change the buttons around. So this is the spectacular core that you see, and you can just make changes in it. Again, there's a grunt listener who will rebuild the library and have it available in our app. So what we did is push the next button to the left side and the previous button to the right side.
So let's start the...
And if we run the test again, and if you look correctly in the test, it said we're going to select the second button.
Yeah, just as you can see now, the next and previous buttons are switched. So
we changed something in the library, and already we have it available in our app that we're developing.
So now it's going to run again all the UI tests against the multiple browsers that we specified.
You see we're testing for some validation. You see the red coming up.
And if we go to the code, you actually see that the test failed.
So this doesn't work because we said click the second button. And it's not the second button anymore, because the second button is now the go back button.
Yeah, so if a team would actually would have actually used the page objects that we created, and we import them on the top. So there's a navigator fixture, we call it, which has a navigator object. We can actually use it. So what we can say over here is navigator.next, which is actually much more readable than using this expression. And we would run the test again. Hopefully everything will be green.
So what page objects are, they allow you to define an interface to your component. So you create a component yourself with an API, so you can do the templates and stuff on it. You also provide a testing API. And this is where we'll look into the code of the protector object, page object for the navigator.
So now all the tests are green again, and teams don't have to worry about when we change functional behavior of a component. Their test, if they use the page objects, will actually still run. And
so we
can
extracted the way of interacting with our component. So we not just gave them a functional generic component with functional generic styling we can change. We can even change the whole functionality, and they don't have to worry about their test breaking. So this really speeds up your whole development cycle. You just implement the thing, you implement the page object, and you don't have to worry ever again that your tests are going to break because we break stuff.
Yeah.
Well, if we break it, of course, your test will fail, but... That's the point of testing, isn't it?
Yeah, so of course we have our own UI tests that are in the component library. Will actually use these components as well, these page objects. So if you look at the page object that we used in the test, there's actually a navigator which has a method header and footer and current and next and previous. And actually in here we use those protractor elements and functions that we don't want teams to use in their UI tests, because we can actually put it in one place now. So
we have a little bit of time left, so we can also look into there in the actual selecting of the elements. Because the way we selected the elements in the first test was a bit dirty, of course. There's a cleaner way for that, and that's the way we're using. So you might wonder, why can this page object deal with the fact that the buttons were changed?
Yeah, I didn't have to change the navigator page object, because we are actually selecting by CSS class over here. So the next button and the previous button have a different styling class. But it will actually show you that writing it in one place and changing it in one place makes it easy to use. So looking at all the other tests, writing this, for instance, navigation.header.breadcrumbs.count is much more readable than expecting an element by ID and then selecting all the breadcrumbs and then selecting all the breadcrumb items and then counting them.
So it abstracts the testing, it makes it also more readable. So really try to do this. When you want to develop Angular with a lot of developers, make sure you write these protector page objects. They're really handy.
This will actually do the same, and your tests are much cleaner and smaller.
So if we remove all the code, we just eliminated the test code by about 70%, and it should still run.
It's so green. So
I guess this is what the main part of what we wanted to tell you. I think you can do Angular on a enterprise scale. We did it. We've been doing it for over a year now. We have automated deployments, and every time we deploy our whole code base at once. We test it at once, and every time we deploy the whole code base again. And like I said, we have these 3 pillars, everything abstracted, very much tested, and we provide page object for the components. I think we've proven you can do it on an enterprise scale so far.
Yep.
Let's go back to the presentation for a few more slides. Well, we did this one, so that's, we did this one as well. Of course, we didn't do it alone. You saw some components, so if you want to look up these guys on LinkedIn, they did a lot of the building of these components as well.
Yeah, so are there any questions? Yeah. The question is, can you use Protractor without Angular? I think you can. But I don't know why you would want to do it, because you can quite easily use WebDriver, Selenium WebDriver to test it. Protractor adds actually behavior to specific methods to expose Angular features, like it waits for Angular elements to be available and stuff like that. So
it is written for Angular, and we get this question a lot. A lot of people want to test their API with Protractor. To me, that doesn't make any sense. It's written for Angular. If you want to test your API, well, do it from Java, create a service client or something to test it. I don't know.
Okay.
Should do the trick. Oh.
Yeah.
Well, of course, we needed APIs to communicate with the backend, and the way we started it, We couldn't just do the whole site in a big bang and migrate it to an Angular app, because that would be too much work. So we started out with using one little box, the search box, and that backend application was the only one returning JSON in the beginning. Yeah. That did pose a little bit more a challenge, because when you time out, the server still returns HTML. So we create an interceptor, and that if we get a timeout, we get back HTML. We have an interceptor in Angular. We look for the session timeout comment. It's a bit hackish, but that's the way it worked. And then we transcribe that, make it into JSON and say, well, you timed out. So we set the proper HTML, HTTP status codes as well.
Yeah, but if you look at the changes that we actually did on the backend, we came from a Spring Web MVC using controllers. We actually use Jersey too, and we needed to make some interceptors which actually check for your if you are who you say you are. So identity management, some checks to see if you are allowed to do this. And the return object, because we used to have JSPs, we actually had a way to represent errors in a way that we did server-side. So if there is an error, we actually needed to create a standard for returning an error object in JSON format, so we can actually use it on the front end to show the same message that we used to have. So
all in all, the backend was quite ready for it. We just had to remove the front-end rendering of JSPs and return JSON, basically. A question up front there? Okay.
Yep.
It started out, I think, Mischa and myself, we started out independently of each other by, there was already some hassle, some rumors, we need to change something. I got to a project which was the search box, and we decided, well, let's see how far we can come by getting Angular into production. Just do it, see where we end up with. You started yourself as well, I think.
Yeah, and I think it took us, well, actually not a lot of time. I think 4 weeks to get something in production. But building the actual build street and all the quality assurance checks, I think it took about 2 months to actually get the first sort of stable build street running. And going automatically, I think took.
And this might sound like this was all thought up completely from the beginning. This was also a learning. So getting the first components to production wasn't that big of a hassle, actually. That surprised me. We got on, but after that there was so much demand that we immediately said, well, we need to ensure the quality, and we need to make sure this doesn't get the same direction the old JSP building blocks were going. So that's why we said, well, we're going to do it. We're going to take some time, and we got some time, which was really cool by ING. I think they really believe in new technology. So that's, and then, well, I think in that 2 months for the first build street releases, and we're still tweaking it until we have what we want. And demands are changing. So
it's a continuous improvement process, because teams, we're working with multiple teams, and we have about I think 60 modules. At least that are already building for production. What happens is that every team does it differently. So the build street improves every time, because teams say, well, we actually want to check this as well. So we'll try to fit it into the build, or if they have a better solution, we try to change it. But it needs to be generic, because they're not the only team that are using it. Every team needs to be able to use it. So when we started out, actually we started with the component library, and then the build, and then the style guide. Now the style guide is leading, and we create the components after the style guide.
But let's throw away the style guide and go material design. That's the new thing. So we'll be busy for quite some time, I think. Any more?
Excuse me?
I heard some guy at the microphone.
It's practical. Did you have something about security or issues or components or?
Yeah, well, in the Angular already provides a lot of security handles for you, so you can. They already specify how you can do cross-site request forgery and JSON vulnerability checks. So we needed to build it into our RESTful API. Other than that, do we have a double-click detection and stuff like that? But yeah, basic.
Angular provides you with the basic mechanisms of doing this this stuff. So implement them. Do it the Angular way. That's all. For the rest, there's not much more to implement, I think.
Keep up to date with the latest Angular version. Yeah.
There's a lot of tools that you mentioned, like grunt and testing frameworks, all the tools we love from Java. Is it a big learning curve for a Java engineer to get to know these tools in JavaScript?
So the question is, we mentioned a lot of tooling, the grunt, the Bower, testing framework, stuff like that. Is there a big learning curve for Java programmers to learn this?
Yeah.
A bit. It's JavaScript, and for many Java writers, that's like cursing, of course.
You can do a lot wrong.
But it's a lot. It is very powerful, and Angular itself has, of course, has a lot of the concepts you're familiar with, like the dependency injection, stuff like that.
Yeah.
For the grunt, well, it's a bit. It's also evolving very, very fast, and there's even the next generation gulp task runner that's new.
Yeah. So you have a Bower, which is actually the dependency injection part from Maven. It actually has transitive dependencies and dependency resolution solving built into it. Grunt is basically just a plain task runner. It's a little bit strange if you're used to standard and going into Grunt. You can do very, very dirty things in Grunt. As Remco already mentioned, Grunt is like mainstream, becoming mainstream at the moment, which moves to Gulp. Gulp is a streaming task runner, which is even more vague, I think. But it is you see a lot of changes in the JavaScript environment.
But don't expect you to get it straight away. You will need some time to dive into it. And if you're experienced with Node.js, that will really help you. So first start to figure out how Node works, how Node modules work, and then move onward from that. Any more?
One question here, Doc.
Yep.
Could you elaborate a bit more about how you modularize your, like, not the application, but the components you provide? Like, do you have different components in different, like, Boa or like repositories, and you pull them all at once, or how does it work?
This is also work in progress. Of course, when we started out, we had very little code, so we just dumped it to what we call the Spectacular core. Then we found out that we were also creating some bigger components that actually interact. Oh, let me repeat the question. Did everybody hear it? I think so. The question was, do we have multiple repositories for our libraries? So do we split them up? And like I said in the beginning, no, because we only had one component, of course, the first one I created. And then everybody started adding more, and then we got into the point that we created components that were also interacting with the backend. For instance, we have a component that allows you to change your email address with the bank. So we said, well, this is really a different kind of beast, so put it in a different repository. And now we have a lot of discussions because it is growing a bit bigger. How do we separate this? And I think the way to go, and the way that Angular is trying to implement it, is divided among functional lines. Yeah. So you have a module with some UI, and maybe you want to...
Yeah, what we used to do is, if we look into the code base, we have like a directory called directives, and underneath we have something like forms. What we now are doing is moving toward bundling it as a functional whole. So if you have a navigator, you probably get a navigator module, which contains all the navigation components that you need. So you have the navigator and the navigator steps and the header and stuff like that. And we will bundle them as one. So a team can actually say, well, we are only interested in the navigator and form validation, for instance, and they're not interested in some other stuff that you create.
Parts you need.
You can package it, but we're still a little bit discussing if we are actually going to create separate Git modules or create multiple
Angular modules
distributed
within,
packages.
So we have time for one more question because there's 1 minute. So again,
what are your thoughts about the Angular 2.0 changes, the conceptual changes that they're going to make?
Good. What we try to
Can you
do,
repeat that?
yeah. What do we think about the Angular changes to Angular 2.0? Well, what we actually try to do is create a component which has one function. And if you look at the way they are going to implement it in 2.0, at least today, is that, for instance, if you look at dependency injection, they now add all the dependencies in the function call for a controller, for instance. Looking into 2.0, they are actually going to use annotations, which we are probably already used to in Java. So you get add inject, and they can actually inject a dependency. Looking at directives, you have, for instance, in Angular 1, you have a directive. In 2.0, they are going to split them up in a component directive, in a template directive. So they're actually making it more explicit, which is, I think, pretty good. And because we have a component library, we can actually change one component at a time.
and if we keep the interface the same,
yeah.
I think we will have it's a lot of work. Migrating to Angular 2.0 will be a lot of work, but we can migrate one component at a time, we hope. But maybe also that changes again with the Angular.
Yeah,
this kind of wraps it up, I think.
Yep.
This was kind of it. Thank you for listening.